Hey everyone, they can't see me, it's Billy Goat again. So what we're going to be doing today is we are going to be setting gains. Um, so I don't I'm not going to do it on these, on the little ones because they're kind of finicky. What I'm going to do is I'm going to do it on my, you can kind of see it here. I'm going to do it on my 1000 SX. Um, I'm going to set the gains. Now, a lot of people think that the gain knob on here, on the sub, on the amp itself, is a volume knob. Turn it up, it gets louder. Turn it down, it gets quieter. That's a crock, okay? There is a right way and a wrong way to do this. The right way to do this is to use a oscilloscope. The wrong way to do it is to just turn it. Meh. No. That will blow your speakers in a hot second. There is absolutely no reason to do it that way. Anyone that does it that way is stupid. Some people are gonna say, "Oh, well, it's cool. Just set it with a multimeter." No, 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 no. You can't guarantee, because what you do when you're setting the gains is you want to get a gain, a signal wave comes to your speaker and it looks like this, right? It's a nice smooth wave. Now, if you set it with a multimeter or you set it by ear or you just crank your gains, what you're going to do is you're going to clip that signal, where your signal, instead of being this nice wave, is going to start hitting flat spots, and then it's going to come down, flat spot, come up, flat spot, come down, flat spot, come up, flat spot. And I'll show you what that looks like. These, I know it says multimeter on here, these are super cheap, okay? This is the best investment I made personally in my tuning purchase kit, my tuning kit. This, it looks like a multimeter. It kind of functions like a multimeter, and it's called a digital multimeter. This right here, got it off Amazon. It was like 40-50 bucks. This is the best money you can spend if you're going to be installing a system or swapping systems out. This thing right here, holy cow. Okay, so what we're going to do first is we're going to unplug our subwoofer. Okay, this wire goes in my subwoofer. We're going to unplug it because if you leave that plugged in, what that does is that if I leave my speaker hooked up to it, speaker sub, whatever, if I leave that hooked up, that voice coil that goes up and down inside the speaker to make the cone move, that voice coil is going to be stuck up in one spot. It's not going to be able to go up and down. It's not going to be able to cool. It's just going to be stuck up there. And it's going to burn your voice coil. That's the number one way to fry your voice coil. If it can't move and a clipped signal, if it can't move, it can't cool. So if it stays up that way, there's no break in that signal for it to go back down and then get hit with a signal again, go back down, hit it again, go back up. If you slow it down, it literally goes like this. But if you send a clip signal to it, it goes up here and then it goes down there. Then it goes up here, then it goes down there. There's no break. So it doesn't have a chance to, take a breather, even if it's for a millisecond. There's no chance for it to take a breather. So you're going to burn that coil. We don't like that. And honestly, I am proud to say I have never blown a sub. I can't talk. I can't say I've never blown a sub, but I've never blown a sub from my tuning. Full disclosure, I did just recently blow a subwoofer, but that was because it was rated for a certain wattage, and I put it on that wattage, and yeah, manufacturer specs were a lie on that, because it was a cheapo sub. I thought it could handle it. It couldn't. So what I'm doing here now is I got my little prongs. Now, I like Another thing I like about, I know I've talked in the past on my other videos about DB-Link Max Core speaker wire. One side is square, the other side is round. So you can tell your positive from your negative. I always use the square wire as my negative and the round wire as my positive. I know you can't really see it. I'm sitting here messing with it. You can't see it. But I always use the square wire as my negative. So, looking at this XT60 connector, you can see, kinda, I don't know, let's see if we can zoom in. You can't. But on these XT60 connectors, one side is rounded off and the other side is squared off. The squared off side is for the positive, the rounded off side is for the negative. And it's got I got little covers on here, but it's actually marked on there which side is positive, what side is negative. So this is my female side. And now look on my male side. The way I have it wired, I have, there's the positive, there's the negative. Okay? So I can sit here and I can take it. I'm going to take my positive probe, stick it in the positive side. I'm going to take my negative probe, and I'm going to stick it in the negative side. So it has contact. And that's going to hold it there. Okay? Now, the next step is turn the car on. I am going to, okay, so what I'm going to do is, since I remember I got the Bluetooth module, turn the Bluetooth on. Now on here, I'm going to connect to my Bluetooth module right here. I heard that beep, so I know it's good. I am going to go ahead and max the volume on my phone. You heard that beep. Max the volume on my phone. Done. Now what this is the Sonic Electronics YouTube channel. What they have on here, you see it has 20 hertz right here. What they have on here, they got white noise, pink noise, brown noise. They got sine sweeps, different levels of sine sweeps going from different frequencies. And then we come down, to here. Okay, these are all test tones. Okay, and they go all the way up to, well, we're at 700, all the way up to 20K. So go down, like test it goes from 20 hertz to 20,000 hertz. So what we're going to do today is we're going to test this with a 40 hertz test tone. Skip the ad. Alright, max my volume on here. Now, it's got the little red light. Move my belly out the way. You can see it's got the little red light that tells me it's on. That tells me it's sending signal. Beautiful. So I'm going to get something right here. So we're going to come to our oscilloscope right here, and I'm going to show you guys what it looks like. Now, amplifiers, car electrical systems are DC, direct current. When it comes to the amplifier, it gets transformed into alternating current because again, the sound waves got to go up, back and forth. So we're going to take this and we're going to set it to AC voltage. There's voltage. You can't really see. There, it's got voltage right here. Then it says AC over here. But this also has a little thing. Nope, wrong one. Hit the little button, and it's got this graph. So, put these back in the right spots. Now, you can't really see, but I'm just going to hold it right here. You can kind of see it's got a little wiggly line. Now, I know that this is going to put out a lot of voltage. Okay, last time I did it, it was like 51.2 volts. So, it's got range. Do that. I'm at a 3 volt range right now. I'm going to multiply that by 10, get that to 30 volts. Then that doesn't want to stay because I keep moving the multimeter around. They don't want to stay. We have our handy dandy screwdriver. Now we've got our gain settings over here on the amp. Try to move around. Got the gain settings over here on the amp. What I'm actually going to do I'm going to go ahead and drop those down to 0. I'm going to grab the camera off the stand I got it on. I'm going to drop my gains down to 0 just for this demonstration. And then I'll actually totally reset my gains for you guys. Okay, so I'm going to come in here. I got my gains for each of my input channels. I'm just going to go ahead and drop all that down to 0. Alright, so now we're going to come here to our test tones and we're going to play it. Huh. I guess my mini subs can play this. Well, we're going to be quick about this then. Okay, so pay attention to right here. You're going to see them get all smooth and wavy, and they're going to go flat on the top and the bottom. The left channel. Now you see right there, they're starting to flatten out on the top. I'm going to bring it back down. That's a clipped signal. I'm going to bring it back down until it's smooth. Reset the tone. Remember I said this is bad for the speaker, so I'm doing this quick. Doing the right channel now. Bring it up. Keeping an eye on it. But watch for when it clips. I don't know if you can see it's starting to distort a little bit. I'm gonna bring back down until the side of the wall, it went from being straight, you can kind of see it go straight, and then it slides over a little bit. We're going to straighten it back up, bring it down a little bit. Huh, that's pretty cool. So I'm at 55.8, 55.9 volts coming out of this amp, going to my sub. Now we're going to turn that test tone off, and then I'll explain to you guys how to do the math on that. Find out what your test tone wattage is. Okay, test tone wattage. This is not going to be what's actually going to your sub. Okay, because remember I said this is just a direct tone, a single tone. There's no modulation to it, nothing like that. So it is not a exact representative of what is going to your subwoofer. This is just what your sub, or what your amp is putting out, okay? Now this works for subwoofer amps, this works for speaker amps, so you can get a general idea of what exactly your amp is putting, if you played a tone, a single tone, what your amp will put out. The way you can measure what your amp is actually putting out is you can play correlated pink noise, okay? Correlated pink noise is going to give you a moderate, it's not going to be spikes like if you're listening to rap, it's not going to be spikes or bass hits or dubstep or anything like that where it's got heavy bass hits. It's not going to give you an exact, unless you sit there with the oscilloscope watching the peaks, the voltage peaks, you're not going to get an exact read on what exactly your amp is putting to your speakers. But this will give you a upper limit as to what your amp is sending to your speakers on a test tone. Some people use this to brag, oh, my amp's putting 3,000 watts. Your amp's not actually putting 3,000 watts to your subwoofer or your speakers, but it can. it can without clipping. All right, so remember I said 55.8, 55.9. So what we're going to do is we're going to use Watt's law. It is a inversion of Ohm's law, utilizing the impedance of the speaker to find out the power levels. It's voltage squared divided by impedance equals power. So we'll do 55.8. So 55.8 volts squared. And then, since I have this subwoofer, this is my Diamond M612 D4. No, before anybody asks, I am not going to sell it. I love this sub. It takes everything I send to it. I beat the brakes off of this thing, and it still takes it, and it loves it, and it eats it, and it wants more. So, no, it's not going anywhere. So I have it wired, it's a D4, so it's a dual 4 ohm voice coil. There's 2 voice coils. Each one is getting is a nominal impedance of 4 ohms averaged. So the way I have them wired to show a 2 ohm load resistance to the amplifier. So we are going to divide it by 2. Since for anybody that wants to be particular with drawing symbols and stuff, there it is. 55.8 volts divided by 2 ohms. I know my handwriting isn't the best. I'm writing big with a marker. Don't judge me. I haven't done that since kindergarten. All right. Because I'm amazing, but I can't do math like this in my head, we're going to do the calculator. So, figure that out. 55.8 squared. So what that comes out to actually is 3,113.64 volts. Or watts. I'm sorry. Watts. So 3,100 watts at 1 ohm, because that is essentially divided by 1. Now, since we are running a 2 ohm subwoofer, we are going to divide it by 2. Okay, that comes out to 1,556.82 watts. And that is what your math looks like. That is how you find out what the peak potential output of your amp at that voltage is to the speaker using Watt's law. And I don't know why more people don't do this. They just usually kick the gain knob to halfway, call it a day. Or they just crank it and use it as a volume knob. That is not the way to do it. Please remember, that is not the way to do it. But it's quick, it's easy, it's simple. That oscilloscope, it's also a digital multimeter, so it's multi-purpose, okay? I do have my analog one, but I mainly use that to check the impedance on the speaker when I'm going to buy some that are used, to make sure that they actually have, okay, if it says it's a 4 ohm speaker, is it actually showing close to 4 ohms? Just to make sure that speaker is not blown and I'm not wasting my money on a piece of crap. But that being said, come on guys, please stop just earballing it, guesstimating by how it sounds. Oh, I can hear distortion. You cannot hear distortion on subwoofer tones. It is impossible, okay? Unless you've got supersonic ears, you can't do it. So that's how you do it. And just make sure you replug your subwoofer back in. You can also do it by taking the wires out of the amp and sticking your terminal up in there. You can get a more secure connection. But that's how you do it. All right, thank you for watching. If you liked it, please hit that subscribe button, click the little bell, like the video, comment on the video if you have any questions. Thanks for watching.